All right, so let's go on with the lesson. The Environmental Club has a piece of wire mesh that they want to form into an open bottom, open top compost bin. So if they make it tall and skinny, because they're going to make a cylinder out of it, if they make it tall and skinny, will the volume be more than if they tip it to the side and make it short and fat? Okay, what's the volume of each? Or is the volume the same no matter what we do? Well, let's take the tall and skinny one. So if we go tall and skinny with this, if we wrap this around, the circumference equals 60 inches. Okay? But is circumference part of the volume formula? No. So what in the heck are we going to do if I know the circumference of it? Because I know the height is 100 here. But I need to find R, right? Is there a way to find R from the circumference? Yeah. Circumference equals 2 pi R. So if we divide by 2, pi R equals 30. If we divide by pi, R equals what? Calculator time. What's 30 divided by pi? 9.5 sounds good to me. So the volume of this is pi r squared h. So the volume is pi times 9.5 squared times the height of 100. Put that straight into your calculator that way. Pi times 9.5 squared times 100. Okay, it's going to be pretty big in cubic inches. It's going to be pretty big. What do we get? 28,352 inches cubed. Okay, now let's do the short fat one. Okay, so then we got to think about it wrapping around this way. Okay, and so the circumference is 100, which equals 2 pi r. So divide by 2. 50 equals pi r. Divide by pi. What does the radius equal? Radius equals 15.9. So the volume equals pi r squared times the height. Well, the height would be this one now times 60. What's the volume of the short fat one? 20,000, 25,000, 30,000, 15,000, 47,653. So the short fat has a lot more volume than the tall skinny. Okay? It's the same piece of wire mesh, just depends how you wrap it. There's a big change in the volume, and that's inches cubed again. Inches cubed. Okay. All right. An oblique prism. I got some in my toys here. Yeah. Or I used to at least. You got a straight up and down prism, and then you got the leaning tower of Pisa prism. Okay? It has a lean to it. Now, if you think about it, I have a whole stack of old relay cards here. Okay? We can find the volume by measuring the length times the width times height. So if I would lean them over like this, does their volume change? No, the volume doesn't change. Whether it's leaning or straight up and down, the volume's the same. So, in an oblique prism, which is the Leaning Tower of Pisa type of thing, prism, the volume is the same. The volume of straight up and down equals the volume for leaning. These volumes are the same. So that's Cavalieri's principle, which states that if two three-dimensional figures have the same height and the same cross-sectional area at the same level, then they have the same volume. All the volumes are equal. So here's two oblique cylinders. This one is 25 tall, and this one is 27 slant height, but 25 tall. Which canister holds the most? Well, what do we know using Cavalieri's principle? They should be the same. What is their volume? The volume equals pi r squared h. So it's pi. What's my radius? What's my radius? Not 20. 20 is my diameter. What's my radius? 10 squared. My height is 25. So if it tells you that you need to put it in terms of pi, do not press your pi button. Okay? Some of the problems will say, state the volume in terms of pi. Okay? So this is still pi. This becomes 100. This becomes 25. So it's 2,500 pi. And that's how you leave your answer. Now, if they want the answer to the nearest tenth, then what's 2,500 pi, or 2,500 times pi? To the nearest tenth. That means how many decimal places? 1. Nearest tenth is 1. 7,800 and something? 7853.9. Okay, we good? Okay. So, the volume of a prism is the area of the base times the height. Okay? Now, if the prism has a pentagon base, you'll have to find the area of the pentagon and take it times the height. If it's a triangle, take the area of the triangle times the height. If it's a rectangle like this, it's just length times width times height. Okay? And cylinder, we've already written that down. So look, what is this shape? What is it called? A triangular prism. It's a prism. What's my base? The 6 times 2 or the 6 and the 4? No. 6 and 4. It's the triangle. It's the shape that's not a rectangle. Okay? So the volume equals the area of the base times the height. So the volume equals the area of the triangle. How do you find the area of a triangle? Well, it's base times height divided by 2. 6 times 4 divided by 2. Times the height. The height is what? 2. The distance between the two bases. Okay? So a base is not always on the bottom. Okay? A base is whatever shape that is not a rectangle in a prism, and the height is the distance between the two bases. 6 times 4 divided by 2 is 12 times 2 is 24. Okay? So you have 24 cubic feet. He has 20 cubic feet of firewood. Will it fit? Yep, it will fit. All right. Marta is repurposing a sandbox as a garden box, and she's buying soil from her school's fundraiser. Estimate the number of bags she should buy. Well, this is 4 feet by 4 feet by 10 inches, and the soil is in bags that are 5 inches by 10 inches by 18 inches. We have a problem right at the start. Do you see any issues we could have right at the start with our dimensions? Some are feet, some are inches. We need them all in the same dimension. Because if we take 4 feet times 4 feet times 10 inches, you don't get 160 feet inches. There's no such thing. Okay? We need to change 4 feet to inches. How many inches are in 4 feet? Well, there's 12 inches in a foot, so 12 times 4 is 48 inches. 48 inches. Now, the volume of the sandbox is the area of the base, 48 times 48 times the height, which is 10. Give me that number.
23,040.
23,040. That's the box. Now the bag. Well, the bag is length, width, height. So the volume equals 10 times 18 times 5. That's 900. So how many bags will fit in the box? How many 900s will there be in here? So do you take this divided by this? What do you get? 25 point. If it's 25.6, how many bags should she buy? 26 bags. She should buy 26 bags of soil to fit in her new garden box. Catherine is using cans of juice to fill a cylindrical pitcher that's 11 inches tall and has a radius of 4 inches. Each can of juice is 6 inches by 2 inches. How many cans of juice will she need? So she has a big pitcher. And she has little cans of juice. So the big pitcher is 11 tall with a radius of 4. The little cans are 6 inches tall with a radius of 2. What's the volume of the little cans? Pi r squared h. This time push the pi button. So we get 24 pi, which is what? Okay, on the big one. Okay, what's your radius? 4 squared times 11. So pi times 16 times 11. So it's 176 pi, which is what as a decimal? So if we take 552.9 divided by 75.4, we get the number of cans that fit in. And about what is it? It should be about 6, right? 6 point something. 7.3. Okay, I can go with that. Kimberly is filling a large canister with laundry detergent. How many boxes of detergent should she buy? Okay, what's the volume of the canister? How do we figure it out? We just take 9 times 14 times 12, and we get the little one, 8 times 11 times 3, which is 264, right? We divide, and we should get, I don't know what we get. 5.7. Okay? Pretty easy. Benito has 15 neon tetras in his aquarium. Each neon tetra requires 2 gallons of water. What's the maximum number of neon tetras that Benito should have in his aquarium? Okay. So 1 gallon of water is 231 cubic inches. He has 15 neon tetras. Can he keep all 15 in there, or is he going to kill off some if he puts them in there? What's the volume of this? Volume is pi r squared h. What's the radius? 8. And the height is 32. So take pi times 8 squared times 32. And press the pi button this time again, because the gallons of water isn't in terms of pi, so you need to press the pi button. What's the volume? If we divide it by 231, how many gallons do we have? 27.9 gallons. How many neon tetras should he keep in there? If each neon tetra requires 2 gallons of water, 13 would be safe. The 14th would be pushing it a little bit. The 15th, one might die. Okay. I don't think we have to do that one, do we? I think you guys got this down pretty well. Okay. There is one that I want to do, though. Yeah, I think you got that down. Let's do this one. All right. So, you have quarters that are each 2 millimeters thick. The volume of your stack of quarters equals 844 millimeters. Okay? 844 millimeters. And the radius of your quarter is, let's just say it's 12 millimeters. How many quarters do you have in that stack? How many quarters do you have in that stack if we know this information? Okay. So, volume equals pi r squared h. Okay. So the volume equals, actually, 844 equals 3.14 times 12 squared times h. I'm going to leave h as h because we don't know how high this original stack is. Okay? So, what's 3.14 times 12 squared?
452.
Boy, I made a bad problem here. If we divide by 452.1, we get approximately a height of 2, right? How many quarters would I have if they're 2 millimeters thick? Just one. I should have made this 8,440. So then it would have been about how much? 20, or it might have been a little different than that. Take 8,440 divided by 4521. What do we get? 18.6. So basically, there would be about 9 quarters in that stack. Okay? So you'll see something like that. There'll be one like that on Friday's quiz. Okay? I think you'll have one like that on your homework. So I'll put out the homework now. We'll call that good for today.